Okay, today's lesson takes us to section 4.7, transformations and matrices. We're going to take some of the transformations we have learned and start using them in back-to-back transformations. So if I did a reflection over the x-axis, could I then follow that by a reflection over the y-axis, and what would happen? That gives you an idea of what we're going to do. So recognize the different properties of matrix operations, how they work, relate the transformations, and then graphs and figures of their transformations, be able to do graphs as well. So moving forward, let's start with what transformations have we learned so far. So you should be able to tick off. It basically means check your little list that we've been keeping. What are the different transformations? So far we could say we've done size change. We've done scale change. We've done reflection over the x, y, and y equals x axis. And now we're going to be talking about how they're related. So after having read the textbook as well as now watching this, how are real number multiplication and matrix multiplication related? So we've talked in the past about if you multiply real numbers, or if you're working with real numbers, you don't even have to be multiplying, but a lot of this is multiplication. If you're working with real numbers in your real number system, you get a real number. So we've always said that it is definitely closed in relationship to real numbers. Commutativity, if you take two real numbers and multiply them in any order, a times b, and then switch it around and multiply them b times a, you will get the same real number answer. Associativity, same thing, but it's three numbers. A times b times c. In the first case, you'd multiply a times b, that answer times c, and then in the second case, a times b times c, but you would multiply the b times c and that answer times a. So again, it would still give us an answer in the real number system. And last but not least, identity element. If you're multiplying anything times a real number and you want to get back to what you started with, you're using that identity element of 1. So it does, the real numbers do have an identity element. So now we better be able to do that same thing for 2 by 2 matrices, because that's what we've been working with. For all of our different transformations, they've been 2 by 2s. And they might go outside that picture a little, but most of them are going to be 2 by 2s. So closure, meaning if I multiply a 2 by 2 times a 2 by 2, will I get a 2 by 2? Yes, we've already shown that. Commutativity. 2 by 2 matrix. Matrix A times matrix B will always equal matrix B times matrix A, and we said no, that does not always work. Associativity, I believe we said yes, it does work. And then the identity element, there is an identity element of for matrices, and we've been working with it. It is the element 1, 0, 0, 1. So everything but that commutativity matrix, being able to switch a matrix around in either order and multiplying to get the answer, that is the only one that's really not working here. So you have to be careful with your multiplication. So moving on. So we had earlier, chapter 2 I believe it was, a composition of a function that said f little circle g, and we said f follows g is how we read that little circle. So that basically told us the order that we need to perform this in. So we would have to perform g, and sometimes we did Euler's f follows g of x. We would have done maybe something like this in f of x notation. So the g of x would get done first, innermost parenthesis, and the f would get done next. We're going to do something similar with that same notation look with transformations. So let's assume we have transformation 1 and transformation 2. They could be any of our size change, scale change, reflection over the x-axis, reflection over the y-axis, or reflection over the y equals x that we have so far. And obviously we're going to be adding to that, so it could be any of these transformations in the end. But if transformation 1 and transformation 2 are from our list there, then t sub 2 follows t sub 1 means just that. We have a pattern. We're going to do 2 of these transformations in a row, and what's going to happen to our original or parent figure. That's what we're talking about. So think about it, and that's where this question leads us. What are the transformations performed on? Every single one of these, size change, scale change, reflection over the x, reflection over the y, reflection over the y equals x, were performed on a shape or image. So we are concentrating on maybe on a triangle, maybe on a rectangle. And every one of those shapes or images then is made up of points. And if it's made up of points, it's going to be a 2 by n matrix. And that's important because order matters, as we found out when you multiply. So with this 2 by n idea is what we're going to perform things on. That means all of these, scale change, size change, reflection, 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 are all 2 by 2 matrices. And if it was a rectangle, it would then be a 2 by 4. There's only one place for that 2 by 2 that stands for the transformation to be placed, and that would be in front of the rectangle. So there's the rectangle, there's the transformation, and you would have to follow that order, that process. So we're going to be looking at that as well as we work through these. So here's our first one. If I said graph, and it looks like a quadrilateral, but let's find out. So we're going to use pink for our parent graph, and it would be 3, 1, 3, 2, 6, 2, and 6, 1. It looks, as we just said, that we basically have a rectangle. So we can see our original parent graph. Now it says, find its image under the transformation of a reflection over the x-axis follows a reflection over the y equals x. Solve graphically by graphing. Okay, we can do that. Let's make our next shape the first transformation. So we're going to go blue, and if we're solving this graphically, we need a reflection over the x-axis follows reflection over y equals x. So we need to take every single one of those points and do a reflection over the y equals x first. And y over x, as we know, meant x becomes y, y becomes x. So our point 3, 1 should become 1, 3. Our point 3, 2 should become 2, 3. Our point 6, 2 should become 2, 6. And our point 6, 1 should become 1, 6. X becomes y, y becomes x. It's all we did there. And so now, in blue, we can see that original parent graph has been reflected over the line y equals x. And if you want to be real specific about it, start thinking that line y equals x is about right there. So we have a very good visual image of what has happened to our shapes. Now, after that, it says reflected over the x-axis. And when we reflect over the x-axis, our x value stays the same, right? No, we're reflecting over the x-axis. So our x value is going to turn to its opposite, and our y value, our x-axis stays the same. Our y value turns to its opposite. So we're folding on our, let's make this one orange, we're folding on our x-axis right there. So, ready? If we have the point 1, 3, it will be 1, negative 3. If we have the point 2, 3, it'll be 2, negative 3. If we have the point 1, 6, it'll become 1, negative 6. And 2, 6 will become 2, negative 6. So there is our final graph image, and it went from first the pink to the blue to the orange. Okay. Now if it says solve using matrix multiplication, I think, double check, I think that's on our next slide. Yep. So if we solve using matrix multiplication, we have to take our original parent graph, which remember is a 2 by 4, and each of our reflection images is a 2 by 2. But ask yourself again, which one's which? Reflection over y equals x is one of those easier ones. So if the point was 1, 0, it becomes 0, 1. If the point's 0, 1, it becomes 1, 0. So this is your y equals x reflection. This is your reflection over the x-axis. So according to the rule, reflection over the x follows reflection over the y equals x. So we must do the y equals x first, which means it's closest, in this case, to our rectangle. And then second, we would do this. Now, we learned in multiplication that you can multiply in any order. The only problem is here, it makes sense to multiply our 2 zeros and 1s before we get involved with any. So we're going to do the innermost parenthesis and do our reflection over the x followed by reflection over y equals x. So here we go. First row, first column, because we're going to get 4 numbers here. Remember, 2 by 2 times a 2 by 2 gives us a 2 by 2. 1 times 0 and 0 times 1 is added together is 0. First row, second column, 1 times 1 is 1, 0 times 0 is 0, added together is a 1. Second row, first column, 0 times 0 is 0, negative 1 times 1 is negative 1, added together is negative 1. Last, second row, second column, 0 times 1 is 0, negative 1 times 0 is 0, 0 and 0 is 0. So now all we need to do is multiply that rectangle matrix, 3, 1, 3, 2, 6, 2, 6, 1, times our new matrix for our transformation. So here we go. First row, first column. 0 times 3 is 0, 1 times 1 is 1, add it up. 0 times 3 is 0, 1 times 2 is 2. So it looks like our x values are staying the same. Now let's go to the bottom. Second row, negative 1 times 3 is negative 3, added to 0 times 1. And so it looks like we're getting the opposite value every time we multiply. And so if you look back at our final points, and I'm going to go back that one slide, did we get 1, negative 3, 2, negative 3, 2, negative 6, 1, negative 6 for our values? 1, negative 3, 2, negative 3, 1, negative 6, 2, negative 6 on our final shape. And yes, we did. So it just shows it by algebra, doing the matrix multiplication, as well as graphing, that we do get the same answer. So now this one says if we take two transformations again, and if we let t sub 1 equal reflection over the x-axis and t sub 2 be reflection over the y-axis, find a single matrix to describe the composition transformation. T sub 2 follows t sub 1. Now my question will be, for you to start, does t sub 1 go here and t sub 2 here? Or do we put t sub 2 here and t sub 1 over here? Your symbols tell you the order. And again, reading it, t sub 2 follows t sub 1. The big question here is, they didn't give us a shape. They did give us an image. Well, you have to keep that in mind. And your image, your shape, is a 2 by n. And if n is anything other than a 2, this is going to be screwed up. Your image will always be over here, farthest on the left. So then the thing you want to multiply with it first should be closest to the right. So t sub 2 follows t sub 1 means t sub 1's getting done first, then t sub 2, and so now we would multiply. But let's go ahead and put our matrix that match up there. So t sub 1 is the reflection over the x-axis, which again we said was 1, 0, 0, negative 1. Now the second one, I'll remind you, if you have a hard time, you can put your little visual up here of your two original points and say, okay, what happens to those 2 points when I reflect it over the y-axis, right? So here you go. You're thinking, okay, I'm moving this over to here and that. So where's it going? So the point 1, 0 would become negative 1, 0. The point 0, 1 would stay right where it's at and stay 0, 1. So those would be your two ordered pairs. You can do it with a visual or you can do it in your head because you have it memorized. And now all we have to do is multiply. What is that one matrix we would get if we did any reflection over the x-axis followed by reflection over the y? So we're not really showing an image or a rectangle or a shape this time. We're just showing that matrix multiplication with those two. But if you did it in the other order, you would get a different answer. So here we go. First row, first column is negative, first row times first column is negative 1 times 1. And 0 times 0 added together is negative 1. First row, second column, negative 1 times 0 is 0. 0 times negative 1 added together is 0. Then 0 times 1 is 0. 1 times 0 is 0. And last combination, second row, second column, 0 times 0 is 0. 1 times negative 1, negative 1. So our final matrix for reflection of x following, reflection of y following reflection of x would be the matrix negative 1, 0, 0, negative 1. So with that combination, you now have an example of what do you do if you have the image given, and you would multiply, or graph, and what do you do if the image is not given. You always have to remember that there would be an image, there would be a shape, and that has to be taken into consideration as you do all of these matrix transformations. So bring any questions you have. We should be good to go with order on different matrix combinations from here on out.